As with every hypothesis test, our goodness of fit chi-squared test is going to involve 5 steps. Our first step is going to be to list. Our second step will be to go ahead and write down our hypothesis. Our third step will be to go ahead and find our test statistic. And step 4, p-value. Step 5, our conclusion. So in a lot of ways, every hypothesis test we've done so far has followed the same 5 steps. The difference here is going to be exactly what we do in these steps. And when we go to list, the first thing we'll do is we'll go ahead and list the number of categories we have. We'll list the number of categories we have because a chi-squared table uses degrees of freedom. And degrees of freedom for chi-squared goodness of fit is the number of categories minus 1. Our next step will be our hypothesis. Our null hypothesis is that the distribution fits. Now this is going to be extremely dependent on what type of distribution we're trying to fit. That is, we might try and say, well, does the university reflect the city itself? Or does the makeup of our classroom reflect the population of Loyola? So it'll really just, once again, depend on exactly what population we're trying to fit. HA will be the opposite, as it always is. That is, either the distribution fits with H naught, or the distribution does not fit. And at this point, it should kind of make sense why we call this a goodness of fit test. That is, either the distribution fits, or we can say we have enough evidence to say it doesn't. Our test statistic, well, it's a chi-squared test, so we'll be calculating chi-squared. And chi-squared is calculated by taking the summation, or the addition, of all of our observed minus our expected squared divided by our expected. So we'll follow the same steps to find chi-squared and goodness of fit as we will when we do a test for independence. Our p-value will use the chi-squared table. And then our conclusion will revolve around the same things all of our conclusions revolve. That is, we'll compare our p-value to 0.05. If it's greater than 0.05, we will fail to reject. What this will mean is that the distribution may fit. Notice we never say for sure it does. We say, okay, we don't have enough evidence to reject. It may fit. Our other option is the p-value is less than 0.05. If it's less than 0.05, we reject H naught, just like we always have, which means the distribution does not